So we're going to do example 4, which is exactly the one I went to first time. Write down terms in x to the power of 4 and x to the power of 3 in the expansion of 1 plus 2kx to the power of 6. Then we're going to find k if those terms in that and that have coefficients in the ratio of 2 to 3. Cool? Sound difficult? The silence is golden. Okay, what do? It's similar to the ones we've just done, but what are we going to do?
Write down the terms.
Okay, so we've got 1 plus 2kx the power of 6. So we're going to write down the terms for x to the power of 4 and x to the power of 3. So in other words, we're not bothering about the bits beforehand. Cool. So what's our coefficient going to be? No, sorry, what's our, Pascal? Ooh, close. 15.
Times
2kx to the power of, oh, sorry, that's squared. Why are we going to need to do that?
Who knows?
You don't need to do that one. You could have just done the next one. Sorry, that's my bad. 2kx to the power of 3. What's the next one? 15 again. The reason we've done those ones is just to show you that it's symmetrical and it's coming back down. Okay, and we go plus dot dot dot. So we're doing around it. Cool. Which gives you 60 k squared x squared plus 160 k cubed x cubed plus 60 k fourth x fourth plus dot 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 plus. Cool. So you only really needed to do those two. They're the only ones they asked for. We happy with that process? Pretty simple. All right, next bit it says, find k if these terms are in the ratio of 2 to 3. Oh, wow, hang on. I put 60. I can't count. It ain't 60. It's 240. Sorry, 2 to the power of 4. Why didn't you correct me then? Because it's much more fun to watch me. Huh?
I was writing it down.
Oh, okay, fair enough. All right, so we've got to do it in the ratio of 2 to 3. Now, it's important to look at which order they do it in. Yep. Yep. Okay. A couple of different ways you can do this. You can write it as a ratio and work it out, or you can write it as a fraction and work it out. It's probably easier to write it as a fraction because a ratio is just a fraction. We're all happy with that process. Okay, so we've got 240 k power of 4 over 160 k to the power of 3. Okay, and that's the ratio that it's in. Happy with that?
Wouldn't there still be a K on top?
There is a k on top. No, we haven't. No, we're saying these are the coefficients to 40k to the power, but they're in this ratio. So we know, because we're trying to find what? What are we trying to find? It says it in the first two words in the question.
Yeah.
Find k. Okay, so we're trying to find k. So now what do we do? Yes, that's right. We simplify the fraction. So we get 3 over 2k equals 2 over 3. Happy with that? Which gives us what? We've got 3 over 2 times k. How do we get k on its own? We divide the fraction. We divide because we're inverse operations. So 2 over 3 divided by 3 over 2 will give you 4 over 9. That's right, because you invert and multiply. Oh my God, year sevens. We all good with that? Excellent. My phone is going berserk. All right, that's a good one. We done?